Hello everybody, we're back taking a look at more of the 2001 Grade 8 Gauss paper put out by those folks at the University of Waterloo in their Center for Education in Mathematics and Computing. We're at question number 14 on this Gauss paper. A rectangular sign has dimensions 9 meters by 16 meters and has a square advertisement placed on it. The border around the square is required to be at least 1.5 meters wide. The area of the largest square advertisement that can be painted on the sign is... Okay. So we're given our options there. How about we draw a picture? We've got a rectangular sign and we have to place a square on it. I say a picture would be an excellent thing to do. So 9 meters by 16 meters. Okay. And we have a square placed here. So here's our square, and here's the border. Okay. And we want the border to be at least 1.5 meters wide. So that means this has to be at least 1.5. This distance has to be at least 1.5. This distance here has to be at least 1.5. And this distance here has to be at least 1.5. Okay? Now we want the area of the largest possible square I can place here, the largest possible advertisement we can place. So we want it as big as possible, and it still has to be square. We need to sort of make these borders as small as possible. Now the smallest they can possibly be is 1.5 meters. So what would happen if we made the border around this whole advertisement exactly 1.5 meters? Okay? What would happen then? So if we fill in the border first, we'd have 1.5 meters up here, because it has to be at least 1.5 on either side. So we need at least this sort of a border here. And if we just drew in our advertisement at this point, we get something very large. What would be the dimensions of this advertisement? Well, we have 9 vertically, but 1.5 has already been counted. So this will be 9 meters minus 1.5 minus 1.5. So this will be 6 meters. So it'll be 6 meters in height, and across it will be 13 meters. So if we were just jumping the gun here, we might say 6 times 13, but remember, the advertisement has to be square. So if we were just doing 6 times 13, I believe that would be 78. And we'd circle in A, and we'd be wrong because we don't have a square here. 13 by 6, that's definitely not a square. But we have the elements of the square we want here. So this is the minimum possible border. This border is always going to be there no matter what advertisement we have placed. And so this rectangle, its height could be at best 6, but its width could be all the way up to 13. So the limiting factor or I guess we can call it the limiting is the height. It has to be at most 6 meters. So let's make it as big as possible. Let's take the height to the max and see if we can get a 6 by 6 square. If one of the dimensions is 6, the other one has to be 6 because it's a square. And let's just quickly check. You can probably do it in your head, but we'll just quickly check. Can we put 6 by 6 square in here and still get the required border? 6, 6. Well, up here, that'll be 1.5, that'll be 1.5, and if we assume we're in the very middle, this will be 5, and this will be 5, we will get the border we want. So all the way around the border is at least 1.5 meters. So what's the area of a 6 by 6 square? Because remember we were asked for the area. Well, if it's a 6 by 6 square, 6 times 6. So 36 meters squared, and that's going to be our final answer here. And that is C. So we bubble in C, and we get ready to move on to question 15, which is the halfway point in part B, and hopefully you guys will join me for question 15 in the next video. I'll see you then.